Hi everyone. Till now we have seen different types of automata, that is non-deterministic automata and deterministic automata. So now we are dealing with the next topic, that is called minimization of automata. Automata means mainly deterministic finite automata we are dealing. Then what is the need of minimization? As you know, in earlier design, for one language means the question I have given, that is W ends with 00. So this is the language. For that we have drawn one DFA, but I will say that DFA is not unique. You can draw another DFA for corresponding the same language, that is 00. That is corresponding to a language, you can draw n DFA, that is proven by the theorem. So, but why we need the minimization? So the need of minimization is when we give to the compiler or when we give to the processing, we must need only for one language one DFA must be corresponding. So that was the need of minimization of automata. So I will say earlier, every design we have seen earlier, that is corresponding to one language, the n DFA can be made, that is consistent, but it is not efficient. To be efficient corresponding to a language, we must have a unique DFA. So that is done by our minimization. So in the world, every person has its own choice to draw any DFA corresponding to language, but when we minimize it, we get a unique DFA which will be same for all languages. Okay, so that is said by the minimization of automata. So minimization of automata can be done in different methods, different theories, and different types of solvings are being available. Now I will say the most easiest method that can be employed for minimization of automata. So we will see that in 3 videos, that is 3 examples we will show. This is the most easiest method. There are different methods being employed, so better you master the easiest method, and that will be in your mind when you do the problems and when you write the theories. Okay, so this was our question. So we have 3 states, A, B, C, D, and E is the final state. So first step in minimization is you must check for the productive and non-productive state. So productive states are in any DFA there are 2 states, productive and non-productive states are So what is meant by productive? Productive state means the essential states are called what? Productive state. Non-productive means its occurrence that is checked or that can be bypassed or that can be that existence is not a problem, that is called what? Non-productive state. So productive states which occurrence is essential, it's necessary condition, that is called productive state. Non-productive state means its occurrence can be bypassed or its occurrence is not a significance in your DFA, that is called what? Non-productive state. So which are the non-productive state? You have already said trap state, or we can say dead state. Trap or dead state is a non-productive state. Next one, that is non-productive means unreachable state. First one is trap state, we are trapped, or dead state, and next one is the unreachable state. Okay, next one is the equal states. So these are the non-productive states. So I will say one by one before minimizing this question. So trap state, you have already known what you meant by a trap state. For example, A is, these are the state, and this C is called what? The trap state. Why it is called the trap state? Trap state means there is no, again I am saying, listen carefully what you meant by trap state. Trap state means there is no path to the final state, that is called what? Trap state. Any state that have no path to the final state, that is called what? Trap state. Here C is the trap state, since it have no path to the final state. This can in this situation also C is the trap state because it have no path to the final state. Once again I will say trap state means a state which have no path to the final state, that is called what? Trap state. Okay. In the condition of trap state can't be avoided. Okay, here when we say non-productive state, these are not essential condition, but trap state, in the situation of trap state can't be avoided. We can merge if we have two or more past trap state, it can be merged to one, but trap state as such can't be avoided. That is the main thing you have to keep in mind in the case of trap state. If we have trap state more than one, it can be merged, but trap state as such can't be avoided. We can't avoid this as such in your DFA or minimal DFA. Okay. Next one is the unreachable state. What do you mean by unreachable state? Unreachable state means if C has arrow like this. Okay, so there is no path to reach C, that is called what? Unreachable state. In trap state there is no path to the final, that is called what? Trap state. In unreachable state, that state can't be visited at any time or with any alphabet. You can't visit that state, that is called what? Unreachable state. This can be avoided. This state, if in your DFA you have unreachable state, you better erase it. That state can be bypassed or that state can be erased from your minimal DFA. Next one is equal state. Very important, equal state. Equal state means you can merge two state. For example, if you are merging, okay, there are two states I am saying, A and C. Okay, these states can be merged into one. When if A with A and C with one alphabet, I'd say W, move to the final state. Okay, otherwise A and C with one alphabet W move to the non-final state, this can be merged. Okay, I will say once again, then only you will be clear. For example, A and C with alphabet A, it moves to a state means F. Okay, A and C with alphabet B, it moves to state D. Then this A and C can be merged. So I have already merged this when I say the concept, that is you think it as A and C as two state. For simplicity I have merged this as one. So A and C, there are two state. With A it moves to one state and with B it moves to one state. Then these two states can be merged, that is equal state. So A and C are equal. That means A and C with same alphabet goes to the same state. Okay, same state, or this can be said as same state, that that will be explained by me more. So it's moving with A, it moves to the same state, B, it moves to the same state. This can be said as what? Equal state. Or we can say with A it moves to the final state and B it moves to the non-final state, that can be also be merged. Okay, so A and C can be merged in two conditions. One condition it is that it moves to the same state. With A, one alphabet it moves to the same state. With another alphabet it moves to the same state, it can be merged. Other case is that with A it moves to a set of final state, that final state can be merged, so it can be also be what? Merged. Also with B it moves to the non-final state, which can be merged, it can be also be merged. Okay, so there will be some confusion when I am saying this theory. When you see the example we will be clear about it. Okay, so we look into this example. First of all, you check whether there is any trap state here. Any trap state here? No, there is no trap state here, because all path will be lead to what? Final state. Whether any unreachable state here? No, there is no unreachable state here. Okay, so this contains no unreachable state, no trap state. So we must what? Minimize it. So minimization, For minimization, we take the concept like this. Final state, what is the final state? E is put in one state and all others are put in one set. Okay, so I mark set S1 with non-final state. What are the non-final state? A is the non-final state, B is the non-final state, C is the non-final state, and D is the non-final state. Again, final state is what? S2. Okay, so that is marked by what? E. Then we write the alphabets A and 0 and 1. 0 and 1. So next we have to make the transition. Where are these going? So A on 0 goes to where? A on 0 goes to B. So A on 0 goes to B. B is in set 1. So I write S1. Again I am saying I have made two sets, one for the non-final state and one for the final state, and you mark the transition table for it. So A on 0 goes to B. Where is B lying? B lying in the set S1. So I write what? Set S1. A on 1 goes to what? C. C is on the set S1. So I write what? S1. Okay. B on 0 goes to where? B itself, that is in the set S1. So I write what? S1. Okay. Next, B on the 1 goes to D. D is also in the S1. So I mark it what? S1. Next one, C on 0. C on 0 goes to B. That is in the set S1. Okay. C on 1 goes to itself. That is also in the set S1. Next one, mark for the D. D on 0 goes to B. That is in the set S1. Okay, next one, D on 1 goes to what? D on 1 goes to E, that is in the set S2. Okay, so I have marked till this. Next we have to mark for the E. E on 0. E on 0 goes to B, that is in the set S1. E on 1. E on 1 goes to C, that is also in the set S1. Okay. That's it. So look at this transition table. A, B and C's transitions are same, isn't it? A on 0 goes to S1, B on 0 goes to S1, C on 0 goes to what? S1. This row is same. Also this row is also same. So you must look like this. If here S2, 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 that's also okay. Here S2, 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 that's also okay, because you have to look for like this to make us equal sets, or you must group like that. A on 0 goes to where? That must be gone by B on 0, or A on 1, 2 goes to where? That must be moved by B. If both are equal, both transition for 0 and 1 are equal, you can group it. Okay, so I am grouping this one. Okay, so I group this one. Okay, so what is left in S1? D is left in S1, so I write S1 with D, and also S2 is E. So when I group this state as 1, you make it another set S3 as A, B and C. Okay, so you write for 0 and 1. So don't be confused. You look into the states, sets, and then write it. So D on, so again D on 0 goes to where? D on 0 goes to B. B is in set S3. Okay, D on 1 goes to E. E is in the set S2. Okay, then E on 1. Okay, E on 1 goes to where? C. C is in the set S3, and E on 0 goes to B. B is also in the set S3. And next one, A on 0 goes to B, that is in the set S3 itself, and A on 1 goes to C, that is in the set S3, and B on 0 goes to B itself, that is in the set S3. B on 1 goes to D, that is in the set S1. Now next look into this. C on 0 goes to B, that is in the set S3. S3, and C on 1 goes to C itself, that is in the set S3. Okay, so look at here B. Here we have grouped 3 set A, B and C, but when we remove D from that set and make next set, the equality condition of the A, B and C has been removed. B get difference with A and C in the one alphabet, because when 1 is coming, B is moving to S1, but remaining A and C is moving to what? S3. Okay, so this is B must be removed from here, isn't it? So I am removing that from here. So this was the first step, this was the second step. Now I am moving to the third step. Third step, again S1 I will have D, and S2 I will have E, and S3 I will have A and C, and S4 I will have what? B. Okay, so 0, 1. Okay, so 0 and 1. So look at here, D on 0. D on 0 goes to what? B. Okay, D on 0 goes to B. B is in set S4. Next one, D on 1 goes to E. E is on set S2. Okay, then E. E on 0 goes to where? B. B is in set S4. Next one, E on 1 goes to C. C is in S3. Okay, A on 0 goes to B. B is in set S4. Okay, A on 1 goes to C. C is in set S3. Next one, C on 0 goes to where? B. B is in set S4. C on 1 goes to itself, that is set S3. Okay, next one, B on 0 goes to itself, that is set S4. B on 1 goes to D. D is in set S1. So look at here, all the group have the same transition, D, S4, S2. Look at here, this will be A on 0 goes to S4, A on 1 goes to S3, A on C on 0 goes to S4, C on 1 goes to what? S3. So this transition has been correct. So 0 it goes to the same state, and 1 it goes to the same state. Same state means same set. So till this you have to repeat. So once again I will say, you must start from the start state. So sorry, start state not, you must start from the 2 sets, that is, one is final and other one is the non-final. So first of all, write one set for non-final and another set for the final state, and you mark the transition for 0 and 1. Similars can be similar transition, similar for 0 and 1 comes, same for 0s and 1 comes, that state can be made as another state, and again repeat it. If there is another odd one coming in the state itself, we mark A, B, C as one state, but here look at here, B is being made as odd one since we have divided it into groups. So B, again repeat it with B as another state. Till how you have to repeat, or till where we have to repeat? We have to repeat like the transition up to steps up to which we does not get any odd state inside a set. So that if we does not get any odd state inside a set, that DFA is minimized. So we have we have 4 state in our minimized DFA, that is, D is the one state, next one E is the another state, and A and C can be clubbed. A and C can be clubbed as one state, and B can be another state. Okay, so very simple. When you look into the transition diagram, A on 0, here this is S1, so you mark here S1. After that you can rub, that is the good strategy to be followed. Here it is S2, A and C is S3, and here is S4. To explain, I am saying after that if you practice it you can better avoid it. So D is S1, so D on 0 goes to where S4, so D on 0 goes to S4, D on 1 goes to what? S2. Next one, E on 0 goes to S4 and E on 1 goes to what? S3. Okay, then S3, A on C, A and C on 0 goes to where? S4, and A and C on 1 goes to where? S3 itself. Okay, next one, B on 0 goes to where? S4. Sorry, this is a self loop, I have made a mistake here. S4 itself, and B on 1 goes to what? S1. Okay, so after that you can rub it, or otherwise it's no problem, you mark it with pencil. So when you get this state, once again I am repeating, you must repeat the steps until you must not get any odd one inside a set. The inside a set there must not be odd one. What is the odd one? 0 transition same must be for the inside the set, and 1 transition, 2 alphabet, same transition or same state, it must go inside any state. Till that you have to repeat. Okay, after that you must draw the minimized DFA. Okay, how many state was there? 1 2 3 4 5 state has been there. We have minimized with 4 states, so this is the word minimal DFA. You will be clear, or you will get the concept more clear when we move to the next example. So thank you till now. Thank you.